All right, welcome to section 2. So this section is on blockchains and what they do. They sell blocks. So we're going to cover a little bit of Etherscan and also a little bit of Uniswap in this one. The main thing to remember is that blockchains sell blocks. Blocks are made up of transactions. So what happens is people who want to submit a change to this open public database, decentralized computation, all the fancy buzzwords, whenever you want to make a change to this stuff, change who owns an asset, update records, do an automation like Uniswap, for example, trading assets. They make a transaction and they pay for that transaction to be included in the next block. And transactions generally have like one of two things, right? They're either, hey, I'm transferring this asset, or they're doing some kind of interaction. So swapping something, minting something, making something, all the things that aren't transfer really. So let's go ahead and go to Etherscan really fast. You can kind of see here, should remember this from the previous intro section. Let's just go ahead and grab a random block. Let's just grab this because it's recent. Let's go top to bottom. So we're at this block number, so roughly 15 million something block. They go all the way back to block 1. So this is the point of the blockchain, right? You can go all the way to the very beginning, and you can follow every single block and see what happened, going all the way back. So this is a recent block, happened 1 minute ago. So height, timestamp. There's 120 transactions in this block. Don't worry too much about contract internal transactions. That'll be a little more advanced for this, but 120 transactions in this block. It was mined by this miner. Ethereum's currently proof of work, so people use a lot of electricity to make blocks soon. It'll be proof of stake, so it won't really hurt the environment as much when they make blocks. Whenever you make a block currently in Ethereum, two things happen. One, you get paid from people who are, you get paid from these 120 transactions that are paying to be in the block. And then also you get a block reward. You get rewarded for having made a block. So there's a static block reward. Every block gets 2 ETH. This is the fees from people choosing to have their transactions in the block. And this is burnt, which we'll get to shortly. We're not going to cover difficulty and total difficulty right now, but we will cover 2 other ones. So blocks have a certain size. And what that means is that the amount of transactions happening in them, to keep the records of the transactions, requires memory. Megabytes, kilobytes, you know what those are. So it's not, you've seen some tweets on this maybe from Elon Musk and others about just increase the block size and it's super easy. You can have as much block space as you want. Block space isn't constrained by anything. It's not really true. If you have big blocks, that means the computers, these miners that are making these blocks and storing that data forever, going back to block 1, they have to have better and better computers every month, every year to store all this data. And if only supercomputers can participate in the blockchain and only supercomputers can validate that this stuff's correct and check it and all that stuff, then it's not going to be very decentralized. And Ethereum focuses very hard on being decentralized so that lots of people can kind of participate in this and validate blocks. You'll also notice that there's gas used and gas limit. Essentially, there's not really a hard limit on the memory size. Like every block will have a different amount of memory. But the way it works is that each block will have a limited amount of complexity. And complexity is the gas. So if you add 2 numbers, that costs some gas. If you multiply 2 numbers, that's more gas. If you write something to storage, hey, remember this person's name for some reason, that will have some complexity. And you pay for that complexity. So I'm going to jump a little bit just to this quick part about an example. So I'll go through this shortly in more detail, but let's just skip directly to right here. So imagine you want to go from New York City to Miami. That is a fixed amount of miles. With an average car, that is a fixed number of gallons of gasoline. So 54 gallons of gasoline to go from New York to Miami. This block has a max of 30 million gallons of gasoline allowed, something like that, right? There's a max amount of gasoline that could be in this block. And then I would pay per gallon for this gasoline that gets from New York to Miami. Well, that's kind of like the transaction fees that we saw here. So all of this gas, this 10 million gas, these 10 million gallons of gasoline, people paid 0.9 ETH in transaction fees for that amount of gas. And this will make more sense when we go a little deeper into the transactions, to a specific transaction. And then, like I said, There's also ETH that's burnt. The idea behind burning ETH, so this person got 2 ETH as a reward, 0.9 in fees, and also 0.77 of ETH was burnt. The idea here is that if you include not just paying for transactions to go to blocks and miners make money, right? You can also burn some ETH, and that reduces the supply of ETH, which hypothetically helps everybody, right? If I have 5 ETH out of 100 million ETH, and then years later there's less ETH because a lot of it's been burnt from the two-fold payments, you pay someone to be included in the block and you burn some ETH, then that helps everybody. You reduce the supply of ETH overall, blah, blah, blah. I'm not a huge fan of this, honestly. I think it's a little bit fake, but it's important to know that currently miners get paid a reward for making a block. They get paid directly for including transactions in blocks that people paid after transactions in the block. And they also burn some ETH overall, which affects the, reduces the whole overall supply. So they get this much, and this much is gone forever. So let's go ahead and do the 120 transactions really quick. And so what you'll see here are there's a lot of transfers. Transfers are pretty simple. You also see someone registered in ENS, which I mentioned earlier. You also see a few Uniswap v3. Uniswap is very, very popular. So let's start with a transfer really quick and go into some detail. Let's grab this one. So just like we saw before, transaction hash, this will get us right to this transaction every time. This transaction worked. It's in the block that we were talking about. It happened 7 minutes ago. And this is pretty simple. This person sent this person 0.12 ETH, and it cost them $2.30 to do that. Now, 21,000 gas is an important number. Simple transfers, this is very simple. From this person to this person, this amount of ETH. That's 21,000 gas. If you go back to what we were just saying, here's 54 gallons of gasoline. This is 21,000 gas. If I paid $4.67 a gallon to go from New York to Miami, it would cost me $250. This person paid 0.0073 Gwei. Gwei is 1 times 10 to the negative 9 ETH. It's a lot of zeros. But they paid 73 Gwei per gas. So 54 gallons of gas, 467 each, 21,000 gas, 73 Gwei each. And what happens, which we'll talk about shortly, is that you have to kind of say how much you're willing to pay. And then if you're not willing to pay very much, you won't get included in the next block. People pay to kind of get to the front of the line. So you multiply these two, 21,000 times the amount of Gwei, and this is how much you end up with. They end up paying 0.0015 ETH, 231. Not that great a deal, right? They sent $180 of ETH, and it cost them $2. Much cheaper with PayPal and Venmo, but it took less than 30 seconds. So if you compare it to a wire transfer or Western Union or something like that, this is kind of in the middle of those two as an option. And we're not going to talk too much about base and max and these things. The point is that, like we said before, some ETH got burnt. They paid gas. They paid Gwei per gas to do this transfer, and this was relatively simple. Let's move to a Uniswap one. That might be a little more complicated. Okay. So this person, this is a kind of more complicated transaction. So let's start at the top. The hash, it succeeded. This is the block number. It happened 9 minutes ago now. This person did 2 trades. They swapped hex to USDC, and they swapped the exact same amount of USDC to ETH. So really what happened is the person said, hey, I have hex and I want ether. Maybe there wasn't enough people putting a pile of hex and ether together. There was only people putting a pile of hex and USDC, and then another group of people putting a pile of USDC and ether. So Uniswap had to do the smart thing and route for them. It said, okay, we'll get you from hex to ether, but we're going to have to make a pit stop at USDC along the way. And that's what we're kind of seeing here, is they went from, they went from this to this, and then this to this. It's much easier to look at it from the action part where it's kind of more linear. This costs more money. It's more complicated, right? There's like multiple coins and stuff happening here. This person, they didn't pay as much as they allotted. You could imagine I had 60 gallons of gas, but I didn't need them all. This person kind of just like had this much they could have used this much, but it only cost them this much. So they paid 223,000 gas units. That's how much they needed, and they paid 73 gwei each. So it cost them similar gwei each as before, but it was just more complicated. So if you have a longer drive, it's going to cost you more money. It's going to cost you more gasoline. Same thing here. They might have paid the same price per gas, but they needed more gas, so they pay more because their transaction is more complicated. We're not going to go into too much detail about decoding inputs and stuff like that. There's also a lot of depth on things like logs and stuff like that. For now, if you're able to get a transaction hash and kind of understand that, like, oh, this is what they wanted. They wanted to go from this to Ether, and Uniswap just did everything along the way to make that easy for them. But, they paid like $24 in fees. So going from $13,000 of Hex to $13,610 of ETH, there's some money lost to what's called price impact. We talked about that in the last video, in intro, and then there's also some loss directly for paying for the transaction fee. So definitely not fun to be a trader on Ethereum. Remember, there are cheaper blockchains, but this person wanted to do the transaction. So yeah, that's everything now for this part of blocks, and let's go on to the financials.